Hi, so in this video, we're going to review an important prerequisite skill for pre-calculus, and that's on factoring. Factoring is going to be used throughout the entirety of this course, so that's why we want to build this foundational skill here in the beginning. To factor, we need to be masters of multiplying binomials, since that's what we are going to be trying to get back to. So a binomial would be an algebraic expression with two terms separated out by addition or subtraction. So here we have a binomial x plus 8, and we're multiplying it to another binomial x minus 3. To multiply, we start with distributing. So we're going to distribute the x in the x plus 8 to the whole binomial x minus 3. That x times x would be x squared. X times negative 3 would be negative 3x or minus 3x. Then we distribute the 8 from the x plus 8. 8 times x would be 8x, so plus 8x. And 8 times negative 3 would be negative 24, so we have minus 24. We combine any like terms that we can, and we see that negative 3x plus 8x is 5x. So we end with this trinomial expression, x squared plus 5x minus 24. Now I'm going to give you a moment, so if you'll pause the video, go ahead and try to practice all 8 of these multiplying binomials. And then when you're ready, I'll show what the answers are. You can click play and I'll bring the answers out. All right, so hopefully you did practice all 8 of those. And here are the solutions to those 8. As you're looking at some similarities, hopefully you see that each of these has a quadratic term. That term would be your x squared or a squared, y squared. All of these have a quadratic variable term. Then we have this middle term that is called our linear term. All of these, except for the last one, had a middle linear term that added to be something like 5x or negative 9a, negative 3m. That is all a linear term because that x is to the first power, or that variable is to the first power. And then there's a constant term. That last term, that's negative 24 or positive 14. Minus 54, all of these have a constant term that did not include a variable. Knowing where these expressions come from is helpful when we're trying to undo that process with factoring. So being able to multiply binomials allows us to see the structure of the resulting trinomial, and so we're going to undo this with the process of factoring. There are many ways that people teach you how to factor, and any of them can work. I try to stick to the classic guess and check method. Now there's a bunch of reasons why I prefer this method, but if you know a different method already, you're welcome to use whatever method you know. If you don't already know how to factor, try the guess and check method, and then we'll see if we need to alter that. So this first one is x squared minus 12x plus 35. What we're trying to do is see what things multiplied together to give me this trinomial expression. So when we had x plus 8 times x minus 3, it multiplied out to give me a trinomial expression. And we want to try to undo those things. So we start with a quadratic term. Now this one's x squared, and so is number 9 that we're doing. And that x squared came from a product of x times x. So automatically, I know if I was multiplying two binomials, x times x would multiply to give me the x squared. Then we're looking at the constant term. So I skip over that linear term and jump to the constant term, because that linear term was made up of two different terms. The constant term is a product of the last two parts in that binomial expression. So 8 times -3 gave me -24. So we really want to guess what factors would multiply to give me 35. Then we'll do the check process. So when I guess about factors of 35, luckily this one doesn't have a whole lot of factors. We have 35 and 1, or 7 and 5. So I'm going to try 7 and 5, and conveniently this is the right choice. But I would guess what factors multiply to give me 35, and I'm guessing 7 and 5. What we need to do is check that multiplication. So the guess and check process guesses the factors, and then we double check to make sure that this does combine to give me the -12x in the middle. So in that multiplication process, we knew that x times x was x squared. We know that 7 times the 5 is giving me 35. What we're checking is that the inside multiplication, 7x, and the outside multiplication, x times 5, which would be 5x, we want to know, can that somehow combine to give me the -12x? And that would combine if they're both negative. So -7x plus -5x is -12. That's what we want. And that would only happen if this was x minus 7 and x minus 5. Now we should also verify that -7 times -5 is 35. That does work. So our factored expression is this x minus 7, x minus 5. Let's do one more. All right, so we have b squared plus 11b plus 30. Because I'm looking at that quadratic term, I have b squared. The way that we would get a b squared is if we had a product of b times b. I jump over that linear term and look at the constant term. In this case, that's 30. And there are a few ways that you could get 30 in this case. So one that you might automatically think of is 10 and 3. But maybe you thought of 5 times 6, or 2 times 15, or even 1 times 30. All of these are possible choices for the placement here in the rest of that binomial. So I'm going to guess 10 and 3 for the start. And now I know that this is technically not the right choice. But let's show why we're checking. So I guessed 10 times 3 does give me 30. And now I'm checking that 10 times b, which is 10b, and b times 3, 3b, add up to give me 11b. But these don't. That would be 13b. Or even if they were subtracted, maybe it would be something like 7b or -7b. So no way does this combine to give me 11b. So our guess of 10 and 3 does not actually work. The more you do this, the easier it will be and the less you'll have to check, but you should kind of verify at least in your head. So we would multiply here with the 5 and 6. Let's try that new factor. 5 times b would be 5b, and 6 times b would be 6b. 5b and 6b does give me 11b. As long as they're both positive, we end up with a positive 11b. And they still multiply to give me a positive 30. So our factorization is b plus 5, b plus 6. This is unique. There's no other factorization that's going to give us the original b squared plus 11b plus 30. So pause the video again and try to see if you can factor 11 through 14. And then when you're ready, you can hit play and we'll go through the answers. All right, so if you've already done that, the answers to these down below, 11 was r plus 9 times r plus 2. And the order does not necessarily matter because this is multiplication. You could have r plus 2 times r plus 9 as long as the signs are the same and it's the exact same product. So 12 is x minus 7, x minus 1. 13, k minus 9 times k minus 8. and 14, a plus 3 times a minus 3. 14 was a little special because the term in the middle is actually a 0a. So we wanted these things to add up to 0. And when you try 3 and negative 3, we do get 3a and negative 3a, which combines to be 0a. This is called a difference of squares in this one. Some people treat this as a special topic on its own, and I think the textbook also does. But a difference of squares is anytime you have a difference, subtraction, of two perfect squares, like a squared minus b squared. Here, a squared is a perfect square. So is 9, because 9 is 3 squared. So the factorization should end up as a plus b times a minus b, based off of that difference of squares. All right, let's move into the next section. The next section looks at a greatest common factor. A greatest common factor, often abbreviated as a GCF, is when there's a number, variable, or even both that divides evenly into each term of an expression. So my first rule of factoring is to always look for a GCF. This will help you out, a GCF. I find it is helpful because it reduces the size of some of the numbers that we're working with. It will help you in the long run, because as we look at some harder expressions, some things that are not necessarily quadratic even, you want to factor out a GCF whenever possible. So to do that, we first want to go forward before we can go backward. Here we have an expression 2 times x plus 5 times x plus 3. This is a product of three things now. And when you're multiplying three things, you can only really multiply two things at a time and then multiply the third thing. So I tend to multiply the binomials first and leave that 2 outside. And that 2 is just going to say 2 times whatever the product x plus 5 times x plus 3 is. Well, we already know how to multiply those together. So we get x squared plus 8x plus 15. Now I did some of that in my head, and as you get better at multiplying and factoring, you will be able to do some of this in your head as well. Then we would multiply that 2 to the expression x squared plus 8x plus 15. And we distribute that 2 into this whole expression. So this would say 2x squared plus 16x plus 30. That is our simplified and expanded product. So if we were going to undo that process, we would look at each of these terms and see, is there a GCF? In 2x squared plus 16x plus 30, each of those is divisible by 2. So we could factor out a 2, which is dividing that 2 out as this 2 times a product. So 2 times the x squared plus 8x plus 15 came from dividing a 2 out of each of those terms. And then you would factor your x squared plus 8x plus 15 back to your x plus 5 times x plus 3. All right, so let's look at this first example, number 15. 4x squared plus 32x plus 48. Now in this, the greatest common factor is 4. I know that 2 divides evenly into each of these, but we do want to look for the greatest common factor. So I'm dividing a 4 out of each of those. So 4 times x squared would have multiplied to give me 4x squared. 4 times 8x would have multiplied to give me that 32x. And 4 times 12 multiplies to give you that 48. So all we've done is divided that 4 out of each of these terms. We are undistributing. Now we're trying to factor x squared plus 8x plus 12. That 4 is still part of the product because we want to end up with that 4x squared plus 32x plus 48. However, now that we've factored out the 4, we are trying to factor a new quadratic expression, which is x squared plus 8x plus 12. And the x squared would have come from x times x. We find a product that multiplies to give me 12. That 12 could be 12 and 1, 6 and 2, or 4 and 3. You can guess and then check. I'm going to guess 6 and 2, mainly for sake of time, but 6 times x would be 6x, and x times 2 would be 2x, which does combine to give me the 8x in the middle as that linear term. So we need a positive 6 and a positive 2. For our final answer, I'll erase the checking that I was working on. We end up with just 4 times x plus 6 times x plus 2. That 4 is important because it's still part of that factorization. So for number 16 through 20, you're going to pause and practice each of those. Look for a greatest common factor in each one, and then see if you can continue to factor the remaining trinomial. All right, and then if you're ready, we'll go ahead and go back through the answers. So hit play whenever you are ready. All right, so for number 16 through 20, we should have these following answers. You can pause as you need to, but you'll see that each of these has a greatest common factor. And for the negative x squared terms, I think it's always easier if we factor out that negative as a GCF. That happens because we get into this rhythm of factoring sometimes, and it's much easier when your quadratic term is positive than it is when it's negative. So even for number 20, I would factor out a negative 1 for everything, and then that quadratic term is positive. So x squared is much nicer to work with. All right, if you did look at that last one on the page, you saw 2x squared minus 5x plus 2. And that does not have a GCF. So if it doesn't have a GCF, how do we go about factoring it? Well, we still treat it the same way. And so, let's move back here. The last page has factoring quadratic expressions when a is greater than 1. Now, this is a little specific terminology, but a greater than 1 is talking about your ax squared term. A quadratic expression in standard form is often written this way, where ax squared looks at our quadratic term. Really, I don't want to point just to the a because someone's going to think the a is the quadratic term. This whole thing is your quadratic term, and a happens to be the leading coefficient for that. We had a linear term, and our constant term, c. In the factoring process, we start with that quadratic term. So when a is greater than 1, like 7x squared, we do look for a GCF, but 7 cannot divide into 45 or 18. So we're a little stuck. And this is where the guess and check gets a little harder, but I know that something times something here has to multiply to give me a 7x squared. That would happen with 7x times x. Now we could argue about decimals and multiplying things like 3.5x times 2x, but we're not going to go into decimals. We're looking at integers only. So then, now that I know 7x times x is 7x squared, we look at the 18. There still are several ways that you could get an 18. You could have 1 and 18, or 2 and 9, or 3 and 6. Many of these are possibilities. As you check and get a little bit better, you'll limit some of the possibilities that you have to try. So I know that 1 times 18 technically does multiply to give me 18, but then I'm going to be multiplying 7 times 18. That's a pretty big number, and it's much bigger than 45x. So I doubt that 7 times 18 is the correct route. It still could be 1 and 18. It would just have to be maybe 18 over here with the 7x. Now that might be worth trying because 18x would happen here in the middle, and 7 times 1 would be 7x here. But that's 25x, not 45x. So I know that it's not the factors 1 and 18. We guess and check a little bit more as we need to. So I'm going to try 3 and 6. In the middle, we have 3 times x, which would be 3x. And the outside, we have 7x times 6, which would be 42x. 42x and 3x is 45x. So the factorization that we need is 7x plus 3 times x plus 6. All right, so you want to continue practicing each of these. Look for a greatest common factor first. If there is a GCF, it's going to make your life easier to factor it out in the beginning, because then you don't have to remember to factor it out at the end. So I'm going to go ahead and put the answers up here, and you can check and see how you did on your factorization. All right. So for number 22, you had 2x plus 1 times an x minus 8. 23 was 3x minus 4 times x minus 9. Number 24, there is a greatest common factor. So you should have 2 times 2x minus 9 times x minus 1. And I want to look at this one specifically because some people may have a different factorization. All right, so if I had 4x squared minus 22x plus 18, and I'm trying to factor that, instead of doing the GCF first, some people might have looked at that and just tried 4x times x. And that does work. 4x times x is 4x squared. And maybe you went straight to 18 times 1. This actually does work. If we had 4x minus 18 and x minus 1 here, I get negative 18x in the middle, and 4x times 1 would be a negative 4x on the outside, which is negative 22x. That's what we want. However, this is not a complete factorization. If I look at that factorization, 4x minus 18, x minus 1, this still has a GCF. 4x minus 18 can factor again. So if it can continue to factor, we want to factor all the way. 4x minus 18 is 2 times 2x minus 9. And we have the x minus 1, which is the factorization that I had. But when you factor out your GCF first, it made all of these numbers that we needed to look at a little smaller. So that the numbers of your quadratic, the new quadratic, were 2x squared minus 11x plus 9. 9 has a limited number of factors. It's only 9 and 1 or 3 and 3. So there's less things to check if you factored out your GCF. All right, to check the rest of these, number 25 was 3x minus 7 times x plus 6. 26 was 7x minus 9 times x plus 10. And for 27 and 28, there is a negative leading coefficient, so you might want to factor out that negative first. But that would make this negative 1 times 7x plus 2 times x minus 8. And for 28, I can factor out a -6 for each of those three terms. And our final factorization is -6 times 3x minus 5 times x plus 1. All right, so continue practicing this factoring skill because it's incredibly important. I have actually several videos on factoring, and there's more than one way. So if you understand the AC method, the box method, a butterfly method, or whatever method does make sense to you, you're welcome to use it as long as it is something that you can back up mathematically. All right, so we'll continue on to the next lesson after you have practiced this.